Want to build your own 0 to 30 volt 1 amp power supply without using a single regulator IC? Let's break down exactly how this transistor-based circuit does it. Here's the full schematic. Now let's connect everything step by step and see exactly how each part works together to give us a clean, adjustable output.
Everything starts with a transformer that steps the 230 volt mains supply down to a safer 24 volt AC output. That AC then passes through a bridge of 4 diodes, which flips the negative half of each cycle, so the current only ever flows in one direction. What comes out is pulsing DC, and a large 2200 microfarad capacitor smooths those pulses into a steady voltage of around 33 volts. This unregulated DC is the raw power that the rest of the circuit will shape into a clean, adjustable output.
Now let's follow that raw voltage into the regulation stage. A small current flows through a 10K resistor into the base of a 2N2222 transistor. This transistor works as a driver, and it's paired with a TIP41 power transistor in a Darlington configuration. Pairing them this way multiplies the current gain enormously, so a tiny base current on the small transistor translates into a large current capability at the TIP41's emitter, which is exactly what's needed to deliver up to 1 amp to the load.
At the same time, a portion of the output current flows through a 1K ohm resistor into a 1N4007 diode. Instead of being used to rectify anything here, this diode is forward biased just to create a fixed, stable voltage drop of about 0.6 volts. That small, stable voltage becomes a reference point the rest of the circuit can compare against.
Alongside that, a voltage divider made from a 100 ohm resistor, a 10K potentiometer, and another 100 ohm resistor sits across the output. As you turn the potentiometer knob, you shift the voltage that appears at its wiper. That wiper feeds the base of a second 2N2222 transistor, which acts as the feedback comparator. This transistor constantly compares the voltage set by the potentiometer against the reference held at the diode, and its collector current directly pulls down on the bias available to the driver transistor.
Here's the elegant part. If the output voltage tries to rise too high, the feedback transistor conducts harder, which pulls more bias current away from the driver and TIP41 pair, and the output drops back down. If the output sags, the feedback transistor conducts less, more bias current reaches the driver, and the TIP41 pushes the output back up. This constant push and pull happens continuously, holding the output steady at whatever level the potentiometer has been set to.
Turning that single 10K potentiometer is really turning a dial on the reference point the feedback transistor compares against, and that's the entire mechanism behind adjusting the output anywhere from 0 to 30 volts. 2 more capacitors round out the design. A 100 microfarad capacitor filters the base voltage of the driver transistor, keeping the bias smooth and free of ripple, while another 100 microfarad capacitor sits right at the output, absorbing any sudden load changes and keeping the final voltage clean and stable. Put it all together, and you have a full linear regulator built entirely from a transformer, a handful of diodes, 3 transistors, and a potentiometer, capable of supplying a clean, adjustable 0 to 30 volts at up to 1 amp. That's how this simple circuit delivers a clean, adjustable output. If it helped, like and subscribe for more. See you in the next video.